Hi there. Now, in this example, we're asked to express 3x all divided by x plus 2 times x minus 1 in partial fractions. Now, I'm assuming that you've watched earlier videos in this series where I showed you that if you've got a fraction such as this, let's just copy it down, 3x divided by x plus 2 times x minus 1, that because this fraction contains two linear factors, x plus 2, x minus 1, I showed you that we could rewrite this in the form of a, which is a constant, divided by the first linear factor, x plus 2, plus another constant, which I'll call b, divided by the other linear factor, x minus 1. So if you're unsure of this step, do check out my earlier videos on partial fractions. But what we didn't do in those videos was work out what the values of a and b were. So that's the aim of this particular tutorial. What we do is we take the denominator here, in this case x plus 2 times x minus 1, and we multiply each term, okay, with that denominator. So you're going to get something looking like this. Now normally I wouldn't write this step in. With practice you should be able to see what the result of multiplying each term by this value here turns out to be, because a lot of the factors cancel. In this first term here you can see that by multiplying through by the denominator they cancel out. When you multiply this term here with the denominator, you can see that the x plus 2 cancels out with that factor there. And similarly, when we take this last term here and multiply throughout by x plus 2, x minus 1, the factor x minus 1 gets cancelled out with the factor there, x minus 1. So what we're left with, and this is what I'd normally go from this line straight into this next line, is that therefore 3x would be identical to a times x minus 1, and then we've got plus b times x plus 2. Alright? Now when you get to this stage, what we generally do is we choose a value of x which takes out this term, and then a value of x which takes out this term. In other words, what we need to do to take out this term, to make it 0, we choose x to be 1. And to take out this term, to make it 0, we choose x to be minus 2. And we solve for a and b. So I'll take you through that stage. What we do then is we first of all choose when x equals 1. That will make this bracket here 0, so a times 0 is going to be 0. So we'll end up with 3 times 1, which is 3. And notice now it's an equation, and I'm just going to change the identity sign to an equal sign. And letting x equal 1 here, you're going to have 1 plus 2, which is 3, so you end up with 3b. And clearly if I divide both sides by 3, I end up with b equaling 1. And to get the value of a, what I do now is I make this bracket 0 by letting x equal minus 2. So when x equals minus 2, okay, what we have is 3 times minus 2, which is minus 6, and that's going to equal minus 2 minus 1, which is minus 3, times a, that's minus 3a. And dividing both sides by minus 3 gives us a equals minus 6 divided by minus 3, which is plus 2. So we can put these results together for a and b and say that therefore we've got our fraction here. Let's just copy it in again. 3x divided by x plus 2 times x minus 1, and this fraction here is going to be identical to the constant a over x plus 2. Well, a is 2, so we've got 2 divided by x plus 2. And then be careful here, don't charge in and write a plus sign until you've checked out what b is. b is positive 1, so that's okay, it's going to be plus 1 over x minus 1. But if that's a negative value, which it will be in some examples, you're going to find yourself rubbing out the plus, okay, just to have plus minus. So if that were minus 1, you'd end up with minus 1 over x minus 1. But in this example, it's plus 1 over x minus 1. Okay, so I hope it's given you some idea then in this first example of how to express then something like this in partial fractions, showing you how we work out the constants a and b.